All right, let's get right into it. We're here to break down the science of how athletes get better. You know the cycle. You fuel up, you train, you get fatigued, and then you recover. But what do the actual numbers say about making each of those steps better? We're going to follow the hard data to see how peak performance is really built. So, here's our game plan. First, we're going to look at what's actually powering the body. It's different engines. Then, we'll get into how to measure the gains you get from training. After that, we'll look at the data behind pushing it too far, and finally, we'll dive into what science says is the best way to recover.
Okay, first things first. We have to understand what powers our movement. And, it's not like your body just has one big gas tank. It's way smarter than that. It actually runs on 3 totally different energy systems, and which one it uses really just depends on how hard and how long you're going.
Now, this table lays it out perfectly. Check out that top row. For anything super explosive like under 10 seconds, your body uses something called ATP and phosphocreatine. Think of it like a rocket booster. It's instant power, but it's gone in a flash. Then as you go a little longer, say up to 2 minutes, it switches gears. Now you're burning muscle glycogen. And for pretty much anything longer than that, the aerobic system kicks in, using a mix of glycogen and fat for that long-haul endurance.
So here's the thing. Your body is both a drag racer and a marathon runner. It just flips the switch depending on the job. A 100-meter sprint, that's pretty much all that instant ATP-PC system. But running a marathon, that's a masterclass in aerobic efficiency. The key is knowing which system you're trying to improve.
All right, so we know our energy systems, but how does training them actually make us better? This is where it gets really cool, because we can actually see measurable, quantifiable improvements that come from a solid training plan. Which brings us to the big question, right? We all feel like training works, but by how much? Can we actually put a hard number on the improvement an athlete should expect? Well, the answer is a definite yes.
Okay, before we get to the juicy numbers, we got to talk about one key metric, VO2 max. The easiest way to think about it, it's the size of your body's engine. It's the absolute max amount of oxygen you can take in and use when you're going all out. The higher the VO2 max, the bigger and more powerful your engine is.
And boom, here's the proof. Check out this data from a 20-week study on runners who are already well-trained, so these aren't beginners. Even so, their VO2 max, that engine size, went up by 4.6%. But what's even more incredible is their speed at something called the first ventilatory threshold. It's basically their all-day pace. That speed jumped from about 13.4 to 14.7 kilometers per hour. That's a massive 9.4% improvement.
Let's just focus on that 9.4% for a second, because it is so important. That threshold, VT1, is basically the fastest pace you can hold before your body starts building up fatigue faster than it can clear it. So, by making that pace 9.4% faster, these athletes can now go way faster for way longer before they really hit that wall. That is a real, tangible upgrade to their endurance.
And this all circles back to that old coaching wisdom that you've probably heard a million times. It's simple, and as the data shows, it's true. Your body gets good at exactly what you ask it to do. If you want to get faster, you have to spend some time training fast.
And the power of that intensity is just undeniable. A big analysis looked at high-intensity training in elite athletes. We're talking the best of the best. And the results, which you can see right here, are pretty mind-blowing. For a full 60% of them, high-intensity work had a large impact on their VO2 max. For the other 40%, it was still moderate. So the lesson here is, even when you're at the top, intensity is what pushes you higher.
Okay, but it's not all sunshine and personal bests, right? Pushing this hard has a dark side. There is a super fine line between training that makes you better and training that just breaks you down. This is that razor's edge between good fatigue and bad overtraining.
So, let's get one thing straight. Overtraining is not just feeling tired after a hard workout. No, this is a chronic condition. It's when your performance drops for a long time because the stress of training has totally overwhelmed your body's ability to bounce back.
And get this, it's way more common than you'd probably guess. Look at these numbers. Some studies show that up to 60% of elite runners deal with symptoms of overtraining. 60%. Even in college athletes, it's still 10%. This is a very real, very present danger.
And you've got to know the difference here, because it's a big deal. There are levels to this. Overtraining is kind of the first warning shot. You catch it early, maybe a few easy days will fix it. But if you ignore it, you risk something way worse called central nervous system fatigue. That's when your brain literally starts pumping the brakes on your muscles to protect you.
and that can take weeks or even months to recover.
So if training can push us to that breaking point, how do we best come back from it? This is where we need to look at the science of recovery. The idea isn't just to stop, but to actively help your body repair itself and get stronger.
I mean, you've seen it all, right? There are a million gadgets and potions out there promising to make you recover faster. But when you're really sore, what actually works? We gotta cut through the noise and see what the evidence actually says. Okay, this chart looks a little intimidating, I get it, but it's actually super powerful. It's called a forest plot, and it basically mashes a ton of different studies together into one picture. This one is comparing cold water immersion, yep, an ice bath, to other methods for dealing with muscle soreness the next day. Each of those horizontal lines represents a whole separate study.
All you need to know to read this is one simple thing. See that vertical line right down the middle? That's our 0 point. It means no effect. Any dot to the left of that line means the ice bath worked better. The further to the left it is, the much better it worked. Simple, right?
So when you boil all that data down, the takeaway is pretty undeniable. For muscle soreness, taking an ice bath consistently works better than just light activity, and it beats out contrast therapy or a warm bath. The data is clear that cold plunge is one of the most effective, science-backed tools you have for bouncing back.
All right, so let's put it all together. Peak performance is a data-driven cycle. It starts with fueling the right energy systems for your goal. Then you use structured training to get those measurable gains, like that incredible 9.4% speed increase. You have to be smart about avoiding overtraining, which we know can hit up to 60% of elite runners. And finally, you use recovery methods that are proven by data, like cold water immersion.
So, at the end of the day, the data gives us the roadmap. It tells us what works, how much it works, and what the dangers are. So I'll just leave you with this one question. Now that you know the numbers, which part of your own performance cycle are you going to focus on changing first? Thanks for tuning in.